Good morning, good afternoon, good evening, ladies and gentlemen. And in today's video, we're going to look at factoring complex trinomials. Now, we looked at factoring simple trinomials in a previous video, which basically meant that the number beside the x squared, the coefficient as we called it, was a number that was not bigger than the number 1. In this case, though, you can see that the number beside the x squared is 2. Which is definitely a number that is bigger than 1. So does this make this question a complex trinomial? Yes and no. The first step you should always do in any kind of factoring question, should be to find any common factors. That should always be your first step. And in this case, if I look at this question, I have a 2, I have a 6, I have a 4. All of these are divisible by 2. So let's see what I have when I get rid of the 2. So I'm going to divide them all by 2, which leaves me with x squared plus 3x plus 2. Well, when I look at it now, the number beside x squared, well, there's no number beside x squared, so we'd assume that that is a 1. So this is really just a simple trinomial in disguise, in which case we would just do the same strategy we did before, so that 2 stays outside. And when we look at this case, we look at the 2, and we have to ask ourselves, let's do our product sum table. So we want numbers that multiply to give us 2 and add up to give us 3. So there's only 2 factors for 2, and that's 2 times 1. And of course, 2 plus 1 gives me 3. So this works. So that means I'm going to have x plus 2, because it's positive 2, and x plus 1. And that's it. That's all. It's all factored. There's nothing else I can do there. There's nothing else common. So what happens then when I can't get rid of the number beside the x squared? We're going to look at that in the next slide. Okay, looking at this next example here, we see that we have the number 12, we have -1, and we have -6. They're not all divisible by the same number. So our first step of factor any common terms. Well, we can't do it. There is no common terms. So what would we do in this case? Well, we're going to do the same thing we did for simple trinomials, except instead of looking for which numbers multiply to give me 6 and add up to give me -1, we're going to look at which numbers multiply to give me. So we're going to take your first number there, the 12. We're going to take the -6, and we're going to go 12 times -6. Now, just a brief reminder, remember every quadratic formula is in the form of ax squared plus bx plus c. So our second step is to take the a, multiply it with the c. So you want to take the a multiplied by the c, which in this case is going to be -72. Okay. All right. And that is what you're going to be able to find the product sum of. So your third step would be what multiplies to give AC, but adds to give B. All right, now in this case, B is -1. Okay, so let's go our product sum table again. So product, we want -72, and sum, We want negative 1. So, what two numbers multiply to give us 72? Well, 1 times 72. Well, first of all, that's going to give me positive 72, which is not what I want. I want negative. So right away, this doesn't even work before going to the sum. Even if I went the other way around, it's not going to work either. So what would make the most sense here? Well, this is where knowing your factors and knowing your rules comes into play, because I know that 8 times 9 gives me 72. So, obviously, if I did 8 times 9, I'd get 72, but I want negative 72. So one of these would have to be negative. So let's try it out. Let's go negative 8 times positive 9. That's going to give me negative 72. But if I do negative 8 plus 9, that's going to give me positive 1. That's not what I want. I want to get negative 1. So that leaves me with positive 8 times negative 9, which is definitely going to give me negative 72. And 8 minus 9 is equal to negative 1. So this is definitely what I want. I want 8 times negative 9. So once you find out what that is, your fourth step is to do something called splitting and grouping. So we're going to split the b term into those two factors. So you can do it in any order you want. You're going to leave the 12x alone. It's still going to be 12x squared. And you can either do plus 8x or minus 9x. It doesn't matter which one you go first. Personally, I would probably go with the plus 8x because these would help out in the future, and you're going to see why. So plus 8x minus 9x minus 6. And you'll notice all I really did here, what's 8x minus 9x? Minus x. So all I did is I split the term. Okay? So let me just erase this. So that brings us to we're almost done here, our last step here. The fifth step is to group two terms and find the common factor. Okay, so we can do it any grouping you want. So in this case, I'm going to go 12x squared plus 8x and minus 9x minus 6. You always want to try to make it 2 and 2. So in this case here, I'm going to see, and I only concern myself with 12x squared plus 8x. Forget about the other one right now. So when I look at this, what's common? Well, there's an x definitely between them both. Yep. There's an 8, there's a 12. What's the lowest common denominator? Well, or the lowest common multiple? Well, they're both divisible by 4 at most. So I'm going to do 4x. And that's going to leave me with, well, 12 divided by 4, that's 3. X squared divided by x, that's x. Plus 8 divided by 4 is 2. And x divided by x is 1. 1 times 2 is 2. Which, that's it. Now, forget about that one. Let's focus now on the minus 9x minus 6. So what is common between those two? Well, not the x now, because the 6 doesn't have an x, but there's a 6, there's a 9. I could say they're both divisible by 3. And they also both have a negative, so why don't we just also take that one out as well? So we're going to take negative 3. What's that going to leave me with? Well, negative 9 divided by negative 3 is positive 3x. Negative 6 divided by negative 3, well, negative and negative, positive 2. And now finally, we look at our two terms, and in both of them, they both have 3x plus 2. These are both common, so let's take out 3x plus 2. And if I took out 3x plus 2 from both, what am I left with? Well, I'm left with the 4x here and the minus 3 here. Can I factor either of them anymore? No. And in this case, that shows that it is completely factored. And that is it. That is how you factor complex trinomials through what we call splitting and grouping. Please try this out with other examples. Now, there are other methods that you can use. You don't have to always use splitting and grouping. There is also something called the cross method, which if enough people wish, I can also make a video for as well. Thank you and have a great day.